What I'd like to do with this question is to work out the length of this vertical side, the vertical height of this triangle. Now you cannot assume that these triangles are equilateral. What we can do for certain is, with this vertical height and this side over here, these sides are perpendicular to each other. So we can safely assume that this is a right angle. And this being a line of symmetry for this triangle, it cuts the triangle in half. So for that reason, we can safely assume that this is 5 centimeters. Now, what I want to do is draw this triangle in a bit more detail, a little bit bigger, so I'll just do it over here. And the side that I want to work out is this over here. Just leave a question mark. Now I'm tempted to use trigonometry, and for me to be able to do that, I need to know one other angle other than 90 degrees. If I wanted to, I could work at this angle, or I could work at this angle over here, which I'll highlight back in the diagram there. I could work this angle out. So if I can get that angle, then I can go ahead with trigonometry. So how do I do that? Well, then one thing I've noticed is that angles around a point, this point over here, so going all the way around, angles around a point add up to 360. And what we have here is 5 angles, 5 equal angles. So that's 1, 2, 4, 5. We've got 5 equal angles. So to find one of those angles, all we're going to do is 360 divided by 5. That gives you 72. So each one of these is 72. But we don't need all these 72 degree angles, we can just work with one. If you remember, a while ago I said to you that we can split the triangle in half by drawing a line of symmetry. So right down the middle, like so. So what we have done is we have split the 72 in half. We've cut the 72, we've divided the 72 by 2. So half of 72 is 36. So I'll just highlight that for you in this bigger diagram. It's 36. Now we can go ahead with trigonometry. What we need to do now is label the sides of this right angle triangle. This is the hypotenuse, because it's opposite. The hypotenuse is always opposite the right angle. This side over here is opposite, because it's opposite the angle that we're going to use in our calculation. And there's only one word left over. We've used up opposite, we've used up hypotenuse. Now all we need to say that this has to be the adjacent. Now we need to decide which one of those 3 words we don't need. We need opposite because there's a number that plays a part of this. We need the adjacent for sure, because that's the side we're trying to work out. The side that we don't need in our calculation is the hypotenuse, because there is no number there, and that's the side that we're not after. So now we need to look at which one of those 3 triangles, do we need to use for our calculation. So which triangle has got the words opposite and adjacent? It's clearly the third one. The third one has got the words opposite and adjacent. So now what I will do is substitute the numbers in. Opposite is 5. Adjacent is the question mark there. And x, tan x, is actually tan 36. So now to find the adjacent, we do 5 divided by tan 36. Some people by mistake put tan 36 on the numerator, but you can see clearly at the top we have 5, so 5 goes on the numerator. Do that on the calculator. So I'm going to round my answer to 3 decimal places. So that is the vertical height. The vertical height is 6.882. Now, what if I wanted to work out the area of one of those triangles in my pentagon? So I'm just going to highlight that for you. So this is, I want to work out the area of this triangle. Now, to be able to do that, all you need to do is remember the formula: half times base times vertical height. So you do half multiplied by 10 multiplied by 6.882 to give you the area of that triangle.